Hello.
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 Hi, I'm Julius.
I'm Cheng.
I'm Neil.
I'm Clemmy.
And I'm Alvin.
And we are the Group 16, class of GUP1
and GQRS1.
and welcome to our Minitab tutorial.
Minitab, originally intended as a tool for teaching statistics, and it's a general-purpose statistical software package designed for easy interactive use. Minitab is well-suited for instructional applications, but it's also powerful enough to be used as a primary tool for analyzing research data.
This is the most widely used software for the business of all sizes, small, medium, and large. Minitab provides a quick, effective solution for the level of analysis required in the most of the Six Sigma projects.
It provides a simple, effective way to input the statistical data, manipulate that data, identify trends and patterns, and then extrapolate answers to the current issues.
First, we have the Pareto chart. The Pareto chart stems from an idea called Pareto principle, which asserts that about 80% of the outcomes result from 20% of the causes. The Pareto chart helps you to visualize how this principle applies to data that you've collected. It is a specialized type of bar chart designated to distinguish the critical few causes from trivial many, enabling you to focus on the most important issues.
Second, we have histogram. A histogram is a graphical snapshot of very continuous data. A histogram also reveals if your data are well-shaped or not, and can help you find unusual data points and outliers that may need further investigations.
Gauge R&R assesses the reliability and reproducibility of numeric measurements, attribute agreement analysis, assess categorical assessments such as pass or fail.
Nearly every process has an acceptable lower and or upper bound. Capability analysis shows you how well your process meets the specifications and provides insight into how you can improve a poor process. Frequently cited capability metrics, defects per million opportunities, and sigma level.
This tool helps you determine if your continuous numeric measurements, such as weight, diameter, and pressure, are both repeatable and reproducible. Both when some person repeatedly measures the same part and when different operators measure the same part.
Open the given sample data Minitab file named painthardness.mtw. Painthardness.mtw. Then proceed to statistics, click the ANOVA and the one-way. Then now you can see the one-way analysis of variance dialog box.
So let's proceed in the next steps after opening the one-way ANOVA dialog box. Select response data are in one column for all factor levels. In response, enter hardness. And in factor, enter pain.
To determine the family error rate, we just need to select the Comparisons tab, which is just located here in one-way analysis of variance. So just click Comparisons, and then the comparison procedures assuming equal variances, we have here the 2 key. Select, and then OK. And select OK. Now we have our one-way ANOVA hardness versus pain.
We are now going to interpret the data. The results indicates that the mean hardness values of the 4 different planes are equal. The p-value is 0.004. It is less than the significant level of 0.05. So some of the paints have different mean. Therefore, the null hypothesis can be rejected. In these results, the factor explains 47.44% of the variation in the response. S indicates that the standard deviation between the data points and the fitted values is approximately 3.95 units. Based on the breakdown of means among the different blends, Blend 2 has the lowest mean with a value of 8.57, and Blend 4 has the highest mean with a value of 18.07. Meanwhile, this is revealed in the interval plot. The lowest is in Blend 2 and the highest is in Blend 4. Group A contains blends 4, 1, and 3, while Group B contains blends 1, 3, and 2. Means that do not share a letter are significantly different. Differences between means that share a letter are not statistically significant. Blends 1 and 3 are in both groups. Blends 2 and 4 do not share a letter, which indicates that Blend 4 has a significantly higher mean than Blend 2. It can be noted also in the plot of the differences of means for hardness that the means are significantly different since the interval does not contain 0.
First, choose Graph and Probability Distribution Plot. Then click View Probability and click OK. In the Distribution section, choose Normal and input 9.1 in the mean and 2.2 in the standard deviation.
Under the shaded area, corresponding to the following, select a specified X value. Click the middle icon. This option shows the probability that an 8-week-old baby's smile duration is between two X values. In X value 1, enter 6. In X value 2, enter 12. Then click OK.